I assume you have learned about dot products of two vectors in linear algebra. Essentially, this operation is not different from matrix multiplication that we covered earlier. You only need to be careful that the second vector must be transposed before this operation. See the example below. There is also a function called dot, which takes the two vectors and generates the same result. In linear algebra, we have seen that the cross product is defined for any n-dimensional vectors. However, in MATLAB, we only compute this type of product operation for three-dimensional vectors. If you have forget about the cross product of two vectors, I have provided the mathematical formula here. See how the cross function in MATLAB can be used to compute this type of product operation. In the last part of this section, we will apply our learning to solve a system of linear equations. From linear algebra, we know that such system is computed of n equations with n unknown or variables. We can generate the matrix form as A times X equals B, and we would like to solve this equation for X. Matrix A and B are defined accordingly. So A is an n by n square matrix, and both B and X are n-dimensional column vectors. Now, from linear algebra, we also know that this system may have no solution, or it may have exactly one unique solution, or it may have infinite number of solutions. Here, I have provided three systems regarding each of these cases. You may want to know them to refresh your mind about linear algebra. So how would you solve this matrix system in general? You see that if we can compute the inverse of A, then we can multiply A inverse from the left into the equation and obtain the value of matrix X. Clearly, this requires the calculation of A inverse and then a matrix multiplication of A inverse and the column vector B. There is a small catch that I mentioned earlier. A must be invertible. Otherwise, the system does not have a unique solution. The rest is easy. We know about inv function and we know how to do matrix multiplication in MATLAB. So here is a small example. We have two equations with two variables x1 and x2 as we saw in the previous slides. We first need to form the A matrix and the B vector, then all we need to do is to compute the inverse of A and multiply that into the column vector B. This is depicted in the example below. This is another example. Here I do have three equations with three variables x1, x2, and x3. See that I have again created the 3 by 3 matrix A and the column vector B with three elements. The rest of these calculations is as before.